Okay, so now we're looking at areas under curves and making a connection with the definite integral. Okay, I'm just going to pause because there's a vacuum clean. Okay, the vacuum clean is finished. So in this particular question, I've got y equals x squared minus 1. I want to find the area bounded by the curve, the x-axis, and x equals 2 and x equals 4. So I can sketch y equals x squared minus 1. It's got y-intercepts of minus 1 and plus 1 because you can factorise that pretty quickly. So that gives you the x-intercepts. Otherwise, you're going to have to use graphics calculator to give you the x-intercepts. But anyway, x equals 2 to x equals 4 is an area that's above the x-axis. So that means we can do a definite integral from those two values. So this will give us the answer because the area is all above the x-axis. So we do. Okay, so x squared, add 1 to the power, divide by the power, minus 1 turns into minus x. Substitute the 4 value, substitute the 2 value, and always put a minus in between, and then just let your calculator do all the work. So the answer comes out as 16 2/3, and because we're measuring area, we used to say the area is units squared. So we've got units now. Okay, copy that down and come to the next slide. Okay, so in the next one, I've got areas not all above. So if I was going to find the area under the curve y equals x squared minus 1 and bounded by the x-axis between x equals minus 1 and 3, if we just did that, we don't get the right answer, because if we do this calculation here and we get 5 and 1, we end up getting 5 and 1/3. But what's happened is some of this area has cancelled out with some of that area, so the negative area has cancelled out some of the positive area, and the area isn't 5 and 1/3. Okay, so technically you could say it's unit squared, but that's not the right answer. So come across and have a look. So what we've got is we have to break up the curve into 2 bits. So we're going to go from minus 1 to 1 for one calculation, and then we'll do 1 to 3 in a separate calculation. And the trick is, if we know we've got negative areas, what we do is we use what's called absolutes. So if we put these straight lines on the outside, what that does is when we get a negative area, a negative answer at the end, we just change it to a positive. So when we have a negative area, we use the absolutes, and then for the positive area from 1 to 3, we can just use normal. Okay, so I've done the calculations and done all the substitutions, and just when you get down to here, you change minus 4/3 into positive 4/3 and then add it to 6 2/3. And so the area that we actually wanted was actually 8. Okay, so copy that down. You'll have plenty of practice. Come across the next slide. So there's a few things. So if you know the area is negative, you don't have to do absolutes. And what you can do is you can just, the two numbers can just be switched. So the bottom number becomes the top, and the top number becomes the bottom, and when you switch those over, you'll get the opposite value. So if you don't want to use absolutes, you can just simply switch the values, and that'll turn into a positive answer. Okay. So, how do you know when you've got negative areas? You got to sketch. You must sketch. Okay, and then once you've got the sketch, you have to find the x-intercepts, because that will tell you where the critical values are. Now to do the sketch, okay, use Desmos or use your graphics, okay, and that'll help, and you can find the x-intercepts. But just remember, if the area is all positive, you don't have to do any breakups. Okay, so it's only when you've got unders and overs that you have to do a breakup into 2 different answers. So in this first one, you'll see there's mainly diagrams, and it's pretty straightforward. There's no thinking involved. And here you got to do the sketches, and then watch out for unders and overs. Okay, so I've picked and chosen a few questions. I'm avoiding e's and logs and trigonometry. So it's probably about at least 2 hours worth of work in that. So have fun. See ya.